Hi, and welcome back to Math Class Heroes. I'm Gabriel, and today we're gonna make a different video. We're gonna make a true or false video. Now, I know that facing a true or false problem could be a little bit scary, but they are important because they help us understand how much we really know about a specific topic. And today, we're gonna find out how much we really know about differentiable functions. Now, throughout this video, I'm gonna be presenting a series of statements for you to guess whether they are true or false. You will have a few seconds to think about these questions, but if you need more time, you can simply pause the video and carry on whenever you'd like. Remember that if you think that a statement is false, you have to present a counterexample, and if you think a statement is true, you have to prove it. Are you ready? Let's go then. For the first statement, we have that every differentiable function is continuous. Is it true or false? This statement is true, and I'm sure you guessed it right, but were you able to prove it? Let's take a number x0 in the domain of the function. Since f is differentiable at x0, then the limit as x approaches x0 of f of x minus f of x0 divided by x minus x0 exists, which means it's a real number, it's not infinite. But as x approaches x0, the denominator goes to 0, and the only way for this limit to exist is that the numerator also goes to 0, which means that f of x goes to f of x0 as x approaches x0, which is actually the definition of f being continuous at the point x0. And since x0 was just any number in the domain of the function is continuous. The second statement is, if f and g are differentiable functions and c is a real number, then f plus g prime equals f prime plus g prime, and c times f prime equals c times f prime. Is it true or false? This statement is also true. To prove it, we write down the derivative limit of f plus g and rearrange it into the limit of f of x minus f of x0 divided by x minus x0 plus g of x minus g of x0 divided by x minus x0. Now, since f and g are differentiable, then each of these limits exists separately. So, using properties of limits, we can distribute this into the derivative limit of f plus the derivative limit of g, which is actually f prime plus g prime. Now, something similar happens when writing down the derivative limit of c times f. Since c doesn't depend on x, we can write this as c times the derivative limit of f, which equals c times f prime. The next statement is, if f and g are differentiable functions and f prime is always greater than g prime, then f is always greater than g. Is it true or false? This statement is false. We could simply consider the function f equals to x and the function g equals x plus 2 over the positive real numbers. We know that f prime is always greater than g prime, but f of 1 equals 2 and g of 1 equals 3. Now, imagine that f and g represent the position of two racing cars. Then this statement will say that if f is always moving faster than g, then f is always ahead of g. But this isn't true. It depends, for example, on the starting point of each car. The next statement is, if f and g are differentiable, then their product f times g is also differentiable. True or false? This statement is true. And actually, there is a formula to calculate the derivative of a product. Do you remember it? F times g prime equals f prime times g plus f times g prime. Let's go and prove it. We write down the derivative limit and add and subtract the term f of x0 times g of x, and rearrange this to have the limit of f of x minus f of x0 divided by x minus x0 times g of x plus f of x0 times g of x minus g of x0 divided by x minus x0. Now, since f is differentiable at x0, this limit goes to f prime of x0. And since g is differentiable at x0, is also continuous at x0. So g of x goes to g of x0. And f of x0 doesn't depend on x, it's a constant. And since g is differentiable at x0, this limit goes to g prime of x0. So all of this equals f prime of x0 times g of x0 plus f of x0 times g prime of x0. The next statement is, if f and g are differentiable, then the quotient is also differentiable. Is it true or false? This statement is false. This would have been true if we would have asked g not to be null. But, for example, if we consider f to be the function x plus 1 and g to be the function x minus 1, then both functions are differentiable, but the quotient is not differentiable at the point 1. Actually, it's not even continuous at that point. The next statement is, if f and g are differentiable, then their composition is also differentiable. True or false? This statement is true. It's the chain rule. Do you remember it? It says that the derivative of the composition equals f prime of g of x times g prime of x. Let's go and prove it. Let's write down the derivative limit of the composition and simply multiply and divide by the term g of x minus g of x0. Now, since g is differentiable, this limit goes to g prime of x0. But g is also continuous. So, as x approaches x0, g of x approaches g of x0. And since f is differentiable, then this limit goes to f prime of g of x0. So, the original limit equals f prime of g of x0 times g prime of x0. Our last statement is, if f and g are differentiable and f prime equals g prime, then there is a constant c such that f equals g plus c. Is it true or false? This statement is true because if f prime equals g prime, then f minus g prime equals 0, which means that the function f minus g is a constant function. So, there is a constant c such that f minus g equals c, which is the same as f equals g plus c. So that's all for today. Leave a comment if you were able to answer everything correctly. Thank you for liking our video. Remember to subscribe. You can follow us on Instagram and Facebook. I'm Gabriel. This is Math Class Heroes. See you next time.